research review. This should be a quick one. Strangely, this isn't really like a piece of published research as much as it is a very high quality write-up on a fun bug in some application I've never heard of. But what we have here is really, really cool application of a parser differential leading to good behavior that's actually exploitable. So I've already read through, I skimmed this morning and I was like, why is this so good? I'm like, oh, it's because it was Jorian's writing, okay. But yes, so not the traditional research review, however. I like this one, it should be a quick one. I know there's going to be some long ones, so I want to have some mix. So I don't really know what this application is or understand its threat model, but I'm guessing it's a help desk application, given the name. Stored XSS through SVG upload with filter bypass. Summary. Bypasses of the attachment view logic with SVG sanitizer make it possible to upload and render an SVG that runs malicious JavaScript. An extension of .png with content type image/SVG plus XML is allowed, and a fallback mechanism on invalid XML leads to unsafe sanitization. I like this. But I like the cross-content type, and then I really like the fallback. Details. The application restricts which uploaded files are rendered inline. Only files considered safe are displayed in the browsers, while others are served with content disposition attachment. So yeah, that's a pretty normal behavior I've seen on some like generic file upload safety stuff to prevent it from being able to render inline. This decision is based on two checks. The file extension, e.g. .png, is allowed, while .svg may not be, and the declared content type, e.g. image/star, is allowed, okay? By using a file name with an allowed extension, e.g. XSS.png, and a content type of image/svg plus XML, an attacker can satisfy both checks and cause the server to treat the upload as a safe image and render it inline, even though the body is SVG and can contain scripted behavior. So this is actually, if you look at like S3 compatible bucket uploads as well, at upload time you specify a content type and it does not have to have anything to do with the extension. So if later down the road there's something that is caring about the extension, the content type can be whatever you want, and that's what it will be when served from that bucket. So that's probably not relevant here, but that same idea applies to like I think S3 compatible storage. I'm not sure how widely that actually goes, but I know for like AWS S3 buckets, like you can very much upload a .png but specify the content type at upload as XML, and it will be, or HTML, and it will be rendered as whatever content type that the server sends back based on what you provided. So here we go. So we have the server then sanitizes SVG content using enshrined SVG sanitizer, and then it's a PHP CTF challenge. You can tell it's a CTF challenge because it's PHP, and that's like nobody would actually run PHP in production. So essentially, it calls it creates a new sanitizer instance. It runs the content through the sanitizer, and depending on if it got a response or a return value from that sanitization, if it doesn't, it tries to do some weird fallback logic, and then it like writes it. If sanitizer returns a falsy value, e.g. false for invalid XML, the code falls back to removing only script tags via simple regex. That fallback does not remove event handlers, e.g. onload, or other namespace XSS vectors, so any payload that triggers the fallback can lead to stored XSS. To trigger the fallback, the SVG sent to the sanitizer must be invalid in the eyes of the library so that sanitizer turns false. If the payload were simply invalid XML for everyone, the browser would not render it and the XSS would not execute. The attack therefore relies on a parser differential. The payload must be invalid or unparsable for the PHP sanitizer, but still valid and executable for the browser. I think I've seen some behavior where the browser is willing to render messed up SVGs, where it like makes it to a certain point before throwing an error. It might be foreign object related. I just remembered that because I've seen broken SVGs that might fail. Man, is this real? I don't know. I don't know what I'm thinking of. Maybe it was XML. Huh. I can't remember. I don't have great notes on this, but I think there might be some behavior. It might be XML actually. and that's a different namespace, and so the rendering behaves differently. I think the SVG has to be valid. I think I'm thinking of XML. Yeah. Yeah. The sanitizer preprocesses the string with some funny thing that tries to cut out PHP tags or something. This strips substrings that look like PHP tags. If critical structure, e.g. an opening tag, is inside or adjacent to something that matches this pattern, this removal can break the document for the sanitizer's parser, e.g. unbalanced or missing tags, causing sanitize to fail and return false. This is key. The same thing can remain valid for the browser which does not perform this replacement. A practical way to achieve this is to wrap a needed part of the document in a construct that looks like a PHP tag to the regex, but it's neutralized in HTML/SVG by comments, for example. And this is so clever. This is so good. This rules so much. So when this kind of thing gets cut out, we end up with that, which isn't valid. The sanitizer sees PHP and removes the matched region, including that and the inner, which effectively removes the opening text tag. So we're just getting it to nuke the opening text tag when it gets processed here, but the DOM, if rendered as an SVG in the DOM, it would just be like, yeah, that's a comment. Yeah, so after that the regex runs the string the sanitizer, after the regex runs the string the sanitizer parses is, and then here's a great string, which notably is not valid XML. The opening text is gone, so the document is malformed, stray/text, and parsing fails, sanitize returns false. What if you had an XML for an object? Alright, sorry. The fallback then only strips script/script, leaving the onload equals alert origin attribute intact, and the file is stored as is. The browser does not apply the PHP tag stripping. It interprets the comments as comments and sees valid SVG with a single text in the onload handler, so the script runs when the image is rendered inline. Yep. So great. So there's the actual POC to upload a fun SVG, and it gives up and says, I'll just remove all the script tags because this isn't even valid XML, and it parses it. And so there, XSS, nice. And then impact, yeah. I'm sure on a ticketing thing, or yeah, you can probably do some damage. So research review points we want to hit, and then I'm actually going to do a special and play with things. So how does this generally apply to BB? Ah, man, that's such a great use of parser differentials in practice. Very, very clever. Definitely, this is the kind of functionality that's worth exploring and digging into. How does it actually sanitize it? Because it's like, oh, it performs sanitization, it's secure. But it's like, well, how is that sanitization performed? Why does this work? I would say the core problem here is this interesting parser differential behavior. I'm sure I want to explore with my ideas for ways to take this, but rating, I rate this. I didn't expect to be doing a research review on a GHS, like on a GitHub security advisory out of Jorian. Let's see. Further research to be done here. I mean, I'm going to perform some further research here. I'm pretty sure that I've seen some behavior where the browser is willing to do bad things with, actually, I don't know what this cuts out. This might cut out foreign objects. I'm not getting a PHP environment set up. I want to see if you can have partially rendered invalid XML as a result of an SVG that would be falsy if going through this, and force the bad logic without needing to rely on this parser differential. Like, I think that just like depending on how it defines error states, it might differ from the browser, which is its own parser differential. So I want to explore that, and I'm actually going to pause and check on that. Okay, whatever. So essentially, if we look at this, we can have a foreign object, which it might get stripped by this library, honestly. But we can have an XML namespace foreign object, and then if we just like have an unterminated tag in it, it will render everything up to it when it tries to render this foreign object and then throw the error. So I don't know how this would behave with this sanitizer. I might actually hit up Jorian about this because this is cool. But like if we refresh this, we have script execution, and it doesn't have to necessarily be a script tag. And then I don't even know how this renders foreign objects. We could, I guess it would make more sense to try to go for, actually I'm not really sure how XML namespace works with, is that insensitive? I think, we could encode this, or we could, man, I don't know. I think that there's a route you could take this, though, that depending on how the parser behaves, I guess if it's just trying to parse, how does it handle foreign objects? I don't, but this is what I was thinking of, so I don't know if this would work, but it is an incomplete SVG that still tries to render parts of an XML foreign object and still throws an error. Don't know. Not gonna get nerd sniped into figuring out. Interesting research review, very good research, very cool parser differential, definitely a lot to think about here, and room for this kind of trick, maybe to try to bypass sanitizers. I have no idea. I don't really play in the SVG sanitization space, but there's a lot of strange browser behavior, especially with how it handles foreign objects, that these might be naive to. So overall, really happy to have read this research because it's cool.